Using the 5 whys. Getting to root cause with 5 whys. There is no more important task in an FMEA than correctly identifying the cause. Finding the root cause is the heart and soul of FMEA procedure. When you have the right cause, it opens the door to solutions. When you have the wrong cause, nothing gets accomplished. By continuing to ask why, the team will be able to discover the progression of cause and effect relationships behind a problem and the root cause that is below the surface. Wisdom begins in wonder, Socrates. Why? The Oxford English Dictionary defines why as a reason or explanation. Origin, Old English, by what cause? A cause is the specific reason for the failure, preferably found by asking why until the root cause is determined. For design FMEAs, the cause is the potential design deficiency that results in the failure mode. For process FMEAs, the cause is the manufacturing or assembly deficiency, or source of variation, that results in the failure mode. What are 5 whys, and how are they used? Many practitioners use repeated questioning of the FMEA team to ensure that the basic why is determined as the cause of a failure mode. This technique, called the 5 whys, can be very helpful, especially when the root cause is not forthcoming. The 5 whys is a technique developed by Taichi Ono, originator of the Toyota production system. It means that by asking why 5 times, the team will be able to discover the progression of cause and effect relationships behind a problem and the root cause that is below the surface. Rationale for 5 whys. Identifying the right cause in an FMEA is one of the most important concepts in effective FMEAs. It is impossible to overstress the importance of fully analyzing and understanding the cause. A half-analyzed cause has little value, as the cause is the heart and soul of the FMEA. Take the example of a projector lamp shattering. If the FMEA team simply describes the cause as overpressure and does not ask why the overpressure, the root cause of wrong gas, is not established. The team will end up trying to solve overpressure, and may miss recommending the correct gas specification. The problem will not be solved. For high-risk issues, it is essential that root cause be identified. 5 whys is a useful technique to help ensure the FMEA team achieves root cause. FMEA tip. Tip: when the FMEA team first identifies the cause of a failure mode, call it cause A, it is useful to ask why the cause occurred. If there is a meaningful answer, then cause A is not the root cause, and the team should continue asking why until root cause is determined. Progression of failure mode and cause from system to subsystem to component. Appropriate failure mode and cause descriptions depend on the type of FMEA being performed. In some cases, the cause in a system FMEA will be the failure mode in the subsystem or component FMEA. The following excerpts from of a bicycle system FMEA, a hand brake subsystem FMEA and a brake cable FMEA will illustrate this concept. Failure mode and cause progression. The FMEA team needs to be aware at what level of the system hierarchy, system, subsystem, and component, the FMEA is being done. Remember, it is always necessary to get to root cause, and associated failure mechanism, for higher-risk failure modes. In this example, the FMEA team can use the recommended actions column of the hand brake subsystem FMEA to require a design FMEA on the brake cable, in order to get to root cause. Excerpt from Bicycle Hand Brake Design FMEA. In the hand brake subsystem DFMEA, cable brakes is not a root cause. The FMEA team recommends require cable DFMEA and PFMEA from cable supplier, in order to get to root cause. Corrosion of cable wiring due to wrong material selected, and fatigue cracks in cable wiring due to inadequate cable thickness, are root causes. The FMEA team can use techniques such as 5 whys to help ensure root cause is obtained. Problem. An FMEA team is performing a design FMEA on a projector lamp. They identify lamp shatters as one of the failure modes, and pressure too high as one of the causes. Is pressure too high a root cause? If not, how can the team use 5 whys to ensure root cause is obtained? Solution. In this example, since the team can ask, "Why is the pressure too high?" and get a meaningful answer, they have not yet achieved root cause. By continuing to ask, "Why?" the team can follow the answers to discover the root cause: overpressure in lamp due to wrong gas. FMEA question. The important thing is not to stop questioning. Albert Einstein.